Hello everyone, welcome back to my channel. In this video we'll talk about linked list. Now a linked list is a way of storing data in a sequence. And unlike the arrays, items in the linked list are scattered across memory. Before we go to the linked list, let's talk about the normal arrays or lists and how they look like inside our computer's memory. Now when we talk about a normal array and you create an array of 10 items for example, let's see what that looks like inside of your computer's memory. So we have a huge chunk of items in your list. Let me do this. A huge chunk of memory that contains every item in your list. And now we have something like this, right? And then we have all of the different blocks for each item inside of your list. Now, so each item would have to be stored next to the previous one inside of a normal array. And these are some disadvantages. Take for example, you are working on a system that is very memory intensive, and you just can't find a block of memory that's consecutively enough spaces to store this entire item. So you can't find a block of memory that is long enough to store this list. That becomes a problem because you have a list of things you want to store. Your computer has enough memory to store it, but because you can't find a block of memory that is long enough in a single block to store this item in your list, it means you can't create a list that will store these items. Now that's where linked list comes in. In a linked list, you can scatter items in your list in different sections of your computer's memory, which will mean that you have some block of memory somewhere, right? Let's say this is a computer's memory. This list of things is a computer's memory. We want to store 5 items in our memory, but now this block is used. This block is used. This block is used. This block is also used. This block is used, and this block is used. Now, even though we have 1, 2 empty blocks, 3, 4, 5, and 6, we have 6 different address blocks in our memory that can store one item, right? And we are only trying to store a list of 5 items, for example. Now we have just enough memory to do that, but because there is no single block of memory that is long enough for 5 items, it means that we can't store a list of 5 things. Now that's where the linked list comes in. A linked list allows you to store one item in your list here, another item here, and chain them together so it's now linked to each other. And now we can now store another item here also, and now say you want to chain this to also this. So now when you start the linked list, you start at this first place. This is the start of your list. Then from here you are able to travel to this place and say this is the second item in my list. And from there you can go to this and say this is the third item in my list. Now let's now visualize on a more basic level how this exactly works. Now let me remove this. Now let's now visualize what a linked list exactly is and how it works. Now a linked list contains a bunch of nodes. Let's explore what a node is and how it works. So now let's say this is a single node in a linked list. Now a node is divided into 2 sections or 3 for different types of linked list. Now in this video I'm going to be talking about singly linked list. Now a singly linked list is one type that allows you to travel from the starting point of the list all the way to the end, and you can't go back. Now doubly linked list on the other hand allows you to start from the beginning. Let's say you get to the second list and you can also go back, find your way back to the previous one. So we'll talk about the doubly linked list in the next video. Here let's talk about the singly linked list. Now inside of this list, let's have this node actually. We have 2 sections. One section for your data and another section that is an address to the next node inside of your linked list. Now let me label this and say this is node, right? And right, let's put this on top. This is a node, and also we can now do this and say this is data, right? And this is no, and this is the reference or less. Now we have a node that contains data. So inside of this data section, you are able to store exactly what you want to store. So you want to store a list of names. Now your first name or the name of the person you want to store will be stored inside of this block of memory or this block of the node. And on the bottom side, which is a reference or the link, we store an address in memory. So we store an address to the next node inside of our linked list. So because the items in our linked list are not directly in front of each other, it means that you have to find your way somehow to the next node because it's somewhere else in memory. You have to find your way to it. Now this section of the node allows us to do that because now we have the address to the next item in the linked list. Now you can just think of this as like a pointing finger saying, okay, you're on this node, this is where you go to get the next node. So that's the address to the next node. Now that we have this item inside of our linked list, this node, we can now build a chain of nodes to form our linked list. So that's basically how it works, a chain of nodes connected together via the link or the reference. Now let me remove this and right. Okay, now let's make another node and connect them together. So now I want to do this. Now we have one more node and one more node. Right. Now, even though we have technically two nodes here, you can't exactly say we have a linked list because they are not connected together. Now, if you start at the beginning of the linked list, which is called the head, so any node that starts a linked list is called the head. Now, we have one node right now, and it's called the head. So we can't exactly travel from this node to the next one because there is no way to do that. So what we do is, let's say this node has an address of A in memory, right? Now when we come here, in order to connect these nodes together, we have to now put inside of this section, instead of this reference or link, we have to write the word or the letter A, just to signify that, okay, when you are here, you find the address of A, and that will be where the next node is going to be located. Now inside of here, we can also have whatever data we want, and then here we need to have the address of the next node. So that's it. That's the way we link the items together. So now let's say this address for this other node is B. Now it means that in order to connect this node to this one, we have to now put the address of here to be B. So now when you start at the head of the node, which is the first node, now after reading your data, see now we can see, let's say we have John for the first name of the person. Now we can say, okay, I want to find my way to the next node. So I come to check the link or the reference. And I see, okay, I need to go to the address of A to find my next node. So I know, okay, this is it. I go to A, and now I see the data. So let's say I see John or David. Now I also want to go to the next node. Now that is B, and I go to the B, and we find also another block of another node which contains data. Now the end of every linked list is a node that has no next value, that has no link or reference to another node. In this case, let's say we have just no value here. That would mean that this is the end of our node because it has no address to another node that we want to go to. Now, what this will mean is that we can now say our nodes are now connected, something like this. So now we can say, remove this. We can now say this and this are now connected, right? And then we can also say this and this are now also connected because they have the address. But this is connected to nothing. So we have a node that goes from here to here and here. Now what happens when we want to add another node to our linked list? And we want to add it in between the A and the B node. In that case, we would have to separate them and link it differently. So let's say we want to add another node. Let me go ahead and draw up one more node here. And now we have one node. We have the data, and we have the address linked to be none, because every time you create a new node, you have the data field, and then the address is always null because you don't know what comes next. So that's why it's null initially. Now let's say the address to this node after we created it was C. Now, if we're going to link this B node to the C node, it means we just update this to C, and now we have linked them together. But now we don't want that. We want this node to connect to this and then this. So we want the list to go from the first A to C and then B, which will mean that the first item in our node will be this, second item will be A, third item will be C, and the fourth item will be B. In order for us to do that, what we have to do is change some values, right? We need to change this link to this of the C, and then also we need to change this B to C, right? So let's try to do that. So now, for us to achieve this successfully, it will mean that we want to make the next item to C this B item, so we don't lose it. So that's what we do first. We change this reference to B, right? That will mean that this node is now connected to this node, right? And now we need to connect this one to this one. What we now do now is to change this value B to C instead. That will mean that this is now connected to this, and now we can remove this particular item. So now when we start in our linked list, now we start from the first node, we go to the A node, right? Because we now have the address of C, we're able to travel to this node instead, and from here we have the address of B, we're able to travel back to the B node. So now the items in our list are now ordered: first item, second item A, third item B, and fourth item C. So that's how to now add different items in different locations inside of your list. We will be implementing linked list in the next video using Python. So to watch that video, go ahead and click it. It's going to be popping up on your screen right now. So thank you everyone. Have a nice day.